Lenco AutoGlide data verification. I'd like to talk about the system itself and how we can verify if we're getting the correct data that the control box needs in order to do auto logic. That information will be coming through your NEMA network similar to this one here. And those two key pieces of information are engine information and GPS. Those are not supplied by Lenco. They are an external bit of information that will be coming through the network and then gathered into the control box itself. So today we're going to talk about how to put the keypad into test mode and then go through and figure out if you're getting your GPS information and your engine information through your network. At this time, when you get on the vessel, what you want to do is you want to turn your battery switches on. And today we're going to utilize this as our battery switch. So we're going to turn that on. We're going to wait a few seconds for the keypad to see if we see any faults. If we don't, we're going to go into test mode by hitting all four of the up and downs until you see the crosshair merge in the center, and then you can release it. Now you should see auto, hold, fave 1, and fave 2. In the last clip, I waited for a few seconds before I went into test mode. I'm going to explain that. When you first initially turn on your battery switch, you want to wait a few seconds, and you'll see that these lights are flashing, and it goes into what we call limp home mode, where you'll see the green crosshair and the 4 outer red tips flashing. The reason it did this is because the box is mounted out of orientation. That box is mounted flat on the surface, when technically it should be mounted vertically, standing upright. The chrome label can either go port or starboard, and the wires need to be exiting facing the engines. The control box has limitations of where it can be mounted and how it can be mounted. The control box cannot lay flat on the deck of a boat like this. It has to be mounted vertically. Also, the wires or the cinch plug needs to be facing towards the engine. The chrome label that says bow and stern can actually be mounted facing either the port side of the vessel or to the starboard side of the vessel. You also have a window of 15 degrees lean both directions, so 0, 15, 0, 15, and then on pitch you also have 15, 0, 15. In order to get the system out of limp home mode, after you have remounted or reinstalled the box in the correct manner, you will have to do a battery cycle. So you turn your batteries off, wait a few seconds, recycle the battery back on, and go back into test mode. After you've waited a few seconds, GPS signal. GPS signal is required for auto logic. It will come from either your multifunction display, a GPS puck, but both of those will be tied into your NEMA 2K backbone, similar to this one, which we are tied into that as well, and then that information is gathered into the control box. How do we know if we're receiving that signal? When you're in test mode, you can press fave 1 one time. You'll see a green crosshair come up, and in this quadrant here, 3 o'clock, you should see scrolling. If you don't, turn on your multifunction display and wait until you get a satellite signal and see if you get scrolling. So we just acquired a satellite signal. That way we know we have GPS signal coming through the network. Engine information. Quadrant 6 is our engine information. Engine information will come from a NEMA 2K certified engine that would have either a gateway or it's already certified NEMA 2000, and it comes directly into the backbone. That backbone will then feed all that information to your other devices like your MFD and also the Lenco AutoGlide control box. In order to see this information here on a CAN-based engine, you have to turn the key switch to accessory on. Some of these key switches do have a lag or a time frame to where it takes in order for the whole system to boot up. Relays can take some time. If it's a Mercury, it's going to go through vessel view, and then vessel view is going to have to populate and then populate that information onto the network. So sometimes you won't see this information immediately. But let's go ahead and turn on our key switch so you understand what this should look like. So now you can see we have scrolling in quadrant 6. This is the second bit of information that we need in order to do AutoLogic. Quadrants 9 and 12. Quadrant 9 is a shift position information. Not all of the engine manufacturers output this, or we capture it, or it's populated on the network. But I can simulate how it should look if you do come across this. And that would be your 9 o'clock, which is shift information. That would be going from neutral forward, forward, reverse. Quadrant 12 is the heading, and the only time that you're going to see that is when the vessel is actually moving. So what I'm going to do is ramp up the RPM and start moving the vessel. So you can see now we have a speed over ground, and you started seeing quadrant 12 scrolling. So in the breakdown of this, we have quadrant 12, 3, 6, and 9. So 12 is heading, 3 is GPS, 6 is engine information, and 9 is shift position. Now that we have our GPS information verified and our engine information verified, I want to talk about actuator verification. When the system is in test mode like this, you can drive each actuator with the buttons on the keypad. And what you want to make sure is that when you press the port side button, the starboard actuator is functioning. When you press the starboard side button, the port side actuator is functioning. Now that we have verified that each the port and starboard actuators are functioning on the proper channel, we can exit out of data verification and test mode. Data verification, fave one time. Test mode, press and hold all 4 of the up and downs for 1 second.